Air pollution is worse than war, smoking, and AIDS put together.
Being advised to stay indoors.
People literally face difficulties in breathing.
99% of the world's population lives in places that exceed WHO guideline limits, with 7.9 million deaths in 2023 attributed to air pollution, i.e. the entire population of Hong Kong or Libya, and around 232 million healthy years of life lost. It is a very serious problem affecting all of us. However, many countries and cities have managed through policies, regulations, education and technologies to significantly reduce air pollution, so the video won't be too depressing, hopefully. In this video, I will try and give you a full breakdown of the global air pollution problem with the help of 3 air pollution experts. From what exactly is air pollution, its effects and its sources, to why we can call it a wicked problem, all the way to solutions, the complexities in implementing them, and to the importance of data, awareness, and public pressure. My goal with this video is to give you a relatively full breakdown of the global air pollution problem, and hopefully you can learn as much as I did from Nicole, Anju, and Lauri from my conversations with them. So what exactly is air pollution? When we talk about air pollution, we generally talk about pollutants, so chemicals and particles that can negatively affect the environment and our health. We have primary pollutants, which are released directly into the air from specific sources such as PM 2.5, sulfur dioxide, and nitrogen oxides. But importantly, you also have secondary pollutants such as ozone and PM 2.5 once again, which aren't emitted directly from sources, but are formed when primary pollutants undergo chemical reactions in the atmosphere. And this is important to remember, as we will see later. Some polluters can claim to not be emitting certain types of pollutants, but due to chemical reactions of the pollutants they do emit, in reality, they are emitting these pollutants, which can be harder to make them accountable. Another quick distinction you will often see is also between ambient or outdoor and indoor air pollution. Notable pollutants you will hear a lot about are firstly PM 2.5, which is probably the most documented and impactful pollutant. PM 2.5 is particulate matter of less than 2.5 micrograms, which is really small as you can see, which is why it has large health impacts and it is very widespread. Another one is nitrogen oxides or NOx, which includes nitrogen dioxide and nitric oxide. A final one I want to highlight here at the beginning of the video is ozone, which is a secondary pollutant. Here it's tropospheric ozone, so not the stratospheric one with the ozone layer, which alongside smog are formed from chemical reactions between NOx, volatile organic compounds or VOX, and sunlight. Another detail which I will talk about more later is that ozone is also a greenhouse gas, and in turn, climate change can exacerbate ozone production. I recommend watching this video if you want to learn more about the details of ozone and smog formation. So when we say 99% of the population lives in places with air quality below the guidelines, what are we talking about? The main ones we talk about are the WHO or World Health Organization guidelines, specifically for PM 2.5. You will see numbers on the screen of micrograms per cubic meter, with the main guideline being 5 micrograms, which might not be interpretable and understandable for you yet, but hopefully having this number in mind here will help you further along the video to understand how much air pollution there actually is. And when it comes to country level guidelines, it also includes how feasible the threshold is in that specific country, which is why there might be discrepancies between what we should be reaching for according to WHO guidelines and guidelines or goals set by countries. It's also important to have a rough idea of what 5 micrograms means when looking at visualizations like this one, as one can easily distort reality like this, which is why having a rough understanding of numbers is important. So why do we have guidelines? Well, because there are severe health effects of high levels of pollution. Firstly, since our lungs are the primary entry point for air pollution into the body, respiratory diseases due to air pollution are very prevalent, such as higher risks of asthma, pneumonia, COVID, pulmonary diseases, and lung cancer. But there are many studies out there that show the adverse health effects of air pollution, with further associations with heart disease and type 2 diabetes, for example. Exposure to PM 2.5 has been associated with increases in poor development of lung, neurological, and brain development in children. Many studies show how pregnant women exposed to high air pollution are prone to adverse birth outcomes. Why? Because air pollution exposure starts before birth, since some pollutants can cross the placenta. Short and long-term exposure to nitrogen dioxide can irritate the airways and increases the risk of hospitalization for people with asthma, which can lead to cases as we saw with Ella in London back in 2013, who was the first person in the world to have air pollution listed as part of the cause of death on her death certificate. We will come back to how air pollution affects people unequally in a bit. And so these health effects lead to deaths. And in 2021, around 8.1 million deaths were attributed to PM 2.5 and ozone exposure, 2023 7.9 million according to the Global Burden of Disease, with 90% of it being attributed to PM 2.5. I have put many papers in the description if you want to learn more about examples of the effects of air pollution. However, measuring deaths from exposure to air pollution can be tricky, so researchers have different ways to estimate it, which this good article goes through. In terms of measuring the impact of air pollution on health, it's not just about quantifying deaths from diseases attributable to air pollution exposure, but also the burden of disease. To measure the impacts on health, we use the burden of disease, which includes different indicators and is generally quantified in terms of disability adjusted life years, or DALY. A DALY is one lost year of a healthy life due to disease or injury, and is the sum of years lived with disability and years of life lost. The first quantifies the amount of years lived with lower health, and the second looks at the number of years that a population would have lived longer if it wasn't for the disease and adverse health effects. But actually, the disease burden is likely to be underestimated in many countries because things such as asthma often get undiagnosed and untreated in many countries and regions. But it's not just our health that's getting affected, although that is the main issue, but also very high economic costs. The associated economic costs generally come from healthcare use and spending, so the Brexit red bus should have looked like this if anything. Loss of economic productivity and income due to work sickness and absences, for example, but many others such as cognitive impacts to agricultural crop loss such as wheat yields.
Right? Because normally when we talk about air pollution, it's only particulate matter. In India, we don't talk about ozone. Right? And ozone is the one that basically impacts the stomatas and the activity that happens within the stomata of the leaves, because of which there are studies which shows that the wheat yield has reduced by almost as high as 30% in India, and the farmers are not aware about it.
Air pollution affects agriculture by disrupting plants' biochemical and physiological reactions, but also can be affected by acid rain, mostly from sulfur dioxide and NOx, which causes soil degradation. A few numbers: in 2015, estimated total losses of wheat production for Europe due to ozone were 23.8 million tons, which for perspective is greater than the annual production of wheat in Ukraine. For those obsessed with GDP, this World Bank report estimated the annual economic damages at nearly 5% of global GDP in 2020, just from outdoor air pollution. That's around $5 trillion, which is something we really should be focusing more on, no? So now we know what the pollutants are and how it affects us. But who or what are the sources of pollution? Overall, air pollution sources include transportation like cars, residential fuel use like cooking, coal burning power plants, agricultural and industrial activities, waste burning, wildfires, and other natural sources. But let's start with an interesting and notorious source: coal-fired power plants and industrial areas. Coal-fired power plants burn coal to produce electricity and are significant sources of air pollution, not to mention carbon dioxide. Sulfur dioxide, PM 2.5, NOx, and other potentially toxic elements are some of the main pollutants emitted. This study here looked at many papers in the literature on air pollution from coal power plants and their effects. Adults living near coal-fired power plants were significantly more likely to report having lung, muscular, skin, and respiratory symptoms, but there are many more papers that show the negative effects. So when I say living near a coal power plant, what do I mean by near? Well, it's actually not 100 meters away. Most studies looking at the health effects of coal plants were in between a 0 and 20 kilometer radius, with some looking at larger radiuses, since in reality, the polluted air can travel for hundreds of kilometers. So let's just visualize this quickly. If we zoom into this coal power plant in South Africa, which is next to quite a lot of people, unfortunately, we can see that this is a 5 kilometer radius, 10 kilometer, and now 20 kilometer radius. So if you live in this area of Joburg, then keep watching the video. This paper here for New Jersey in the US observes that pregnant women living at even more than 30 kilometers away from a coal-fired power plant are at a greater risk of low weight and size births. Millions of people around the world live near coal power plants. Another important detail is that communities living downwind from the coal power plant will experience higher levels of exposure to air pollution than those located upwind. So let's take this case here again. Wind patterns vary a lot, but I found that they come mostly from the north, so the people living here are mostly downwind of the Kelvin power station, which isn't even actually one of the most polluting coal-fired power plants in South Africa. South Africa is notorious for air pollution due to coal-fired power plants, with 6 of the world's 10 worst nitrogen oxides emissions hotspots located in South Africa. 9 of Africa's top 10 NOx hotspots are linked to Eskom-operated power plants, which we will talk about more later. Also, 2 of the world's 10 worst sulfur dioxide hotspots are in South Africa. But there are also many other industrial processes and heavy industries which can heavily increase air pollution, such as steelmaking and cement, due to the reliance on coal for certain industrial processes. Agriculture. Certain regions can experience high amounts of air pollution from crop residue burning. For example, you can see a pattern between high levels of PM2.5 air pollution in certain Indian regions with the time of period where rice residue is burnt around November and December each year. This affects both rural and urban communities, and some studies show that clear increases in respiratory illnesses due to this period of crop burning. Certain agricultural practices like livestock cultivation and fertilizer application also increase ammonia emissions, which is also a precursor for secondary PM2.5 formation when reacting with other gases. And in many areas around the world, there is little to no regulation and monitoring of these precursor gases. For vehicles, you have exhaust emissions and non-exhaust emissions from tire wear, for example. All vehicles, including electric cars, have some non-exhaust emissions, but most emissions truly come from internal combustion engine cars, so fossil cars, let's say, and I will explain later why many times comparisons between electric cars and fossil cars are many times misleading. So, a significant portion of nitrogen dioxide emissions and PM2.5 come from the transport sector, which also includes emissions from aviation and shipping, not just cars. We need to be careful though with not just focusing on PM2.5 and nitrogen dioxide emissions, as other precursor gases are also emitted from transportation sources. In the European Union, for example, certain pollutants like ammonia and nitrous oxide, which is also a potent greenhouse gas, have increased between 1990 and 2023. Part of this is due to the attempts to reduce other emissions. So basically, many diesel and some gasoline cars were equipped with technologies to reduce NOx emissions, but some of the unintended consequences of this solution was to increase other pollutants, such as ammonia through ammonia slips. It's important to mention these pollutants too, because they aren't as monitored or regulated as other pollutants, such as NOx, but still lead to PM2.5 formation. And even if NOx emissions from fossil cars were reduced thanks to certain technologies and filters, I will remind you of Dieselgate, where basically the entire automobile industry selling diesel cars decided to be funny and pollute the air. They basically added devices to their cars that during the lab tests would reduce the NOx emissions of the vehicle to pass the test, but once on the road, the emissions would be much higher. Overall though, high-income countries have seen rapid declines in nitrogen dioxide emissions, but middle and lower income countries have been stagnating or increasing pollution in general, many times due to higher petrol car ownership. Another source of air pollution is indoor or household air pollution from burning solid fuels such as biomass and coal for cooking, heating, or other domestic tasks. This paper looked at 65 countries which are most dependent on dirty fuels and inefficient technologies for cooking and heating indoors. They find an average national indoor PM2.5 concentration of 410 micrograms, which is just mad. And in that study, they find that in 2020, indoor air pollution in those 65 countries caused more than 2 million deaths. But there are also natural sources of air pollution, albeit not as natural anymore. 2024 saw a record high death count caused by smoke-derived PM2.5 from wildfires of 154,000 people. Another mostly natural source of particulate matter is sand and mineral dust, especially in desert, arid and semi-arid regions, such as in Chad. But one way that us humans are affecting the rate and severity of this source of pollution is by exacerbating desertification and land degradation in certain areas of the world. Desertification inherently increases sandstorms, and land degradation from deforestation, misuse of water resources, and overgrazing can make land more susceptible to wind erosion. Now a bit more on secondary pollutants. In the case of India, secondary pollutants are particularly important as it's estimated to contribute to over 50% to overall PM2.5 levels in several regions. Why? Because as we saw previously, if your emissions of precursors such as nitrogen oxides and sulfur dioxides are high, India being number 2 and 1 in the world for these two pollutants, then this creates the adequate environment for secondary pollutants to form, such as ozone. So for example, ammonium sulfate contributes highly to PM2.5 levels in India, but sulfur dioxide is needed for the formation of ammonium sulfate, so without it, you then wouldn't get all of this PM2.5. And as we know, sulfur dioxide emissions are quite particular to coal-fired power plants, with 60% of sulfur dioxide coming from them in India. And so why do secondary pollutants cause confusion in terms of attribution to sources? And do certain actors take advantage of this?
And so the reason that this causes confusion is that when people look at PM2.5. Okay, we've got way too much PM2.5 in the air here. So then they go and ask, okay, who's emitting PM2.5? But that's only half of the story. The other half is all the other pollutants that are emitted as gases and then turn into PM2.5 in the atmosphere. And this is particularly true of industrial and power plant sources, because they typically have, essentially everywhere in the world, they have particle filters or controls of some kind. And so they emit a lot more of some of the what is known as precursors, like sulfur and nitrogen oxides. And so they can go to the data and say that, oh, our PM2.5 emissions are only 1% of the total in this area, so we're completely negligible, and that's completely neglecting the contribution that is 10 times, 20 times bigger that they're making from the other pollutants that they're emitting. The thing is that there's no kind of simple formula to convert the emissions of these precursor pollutants into the concentrations in the air. You need fairly sophisticated modeling to do that. It's easy to miss this part and then create a picture of the sources of pollution that is highly misleading.
So which countries, regions, cities are the most polluted, just to get a global idea? Well, here you can see the most polluted countries based on an annual average, with, for example, Bangladesh having an annual average PM2.5 concentration of 78 micrograms per cubic meter. But that's a national average, so you can already imagine how it is in certain hotspots such as big cities and near industry. You will also see differences of sources, whether natural or human-induced, in different regions and in different years. So some countries in the Middle East and Africa might have higher PM2.5, such as Chad due to mineral dust in the Sahara, others fossil fuel combustion like South Africa, and some more residential like in South Asia. Ozone exposure, for example, is highest in some Middle Eastern countries, South Asia and East Asia. In certain areas, it might be worse in winter months, like here in Delhi from November to February, partly due to seasonal agricultural practices like crop residue burning in those periods, which we saw. In others, like in Brazil, it might be higher in hotter months and thus wildfire season, which climate change is exacerbating. One study even looks at the potential reversal of progress towards lower PM2.5 emissions in the US due to increasing wildfires. So that was the simple side of the video, but now we will delve into more complexities and to the next section. Why can we call air pollution a wicked problem?
So when we talk about wicked problems generally in kind of scientific terms, we're thinking about problems that have these key traits. So they include things such as there's not one solution, there's just kind of better or worse solutions. There's also wrong solutions that aren't going to be tolerated, so there's an opportunity for solutions to go wrong and make a situation worse. There's a lot of rippling consequences, connections to other challenges, varied stakeholders, so people who are both contributing to the problem, but also people who are feeling the impacts of the problem, and they can be varied or the same, or a mix of in some cases. And that these there's not really a clear stop point. So when we're talking about this in terms of air pollution, there's not necessarily a number where we go, right, air pollution's solved now.
So here's one of the definitions of wicked problems, but basically many types of air pollution, many solutions, many different polluters, responsibilities can be badly assigned, etc. So let's go through a few ways how air pollution is a wicked problem. Firstly, we need to understand that it's not just a local issue, but a regional one or even international one.
Ministry also realized that air pollution, it's not a localized issue. Rather, it's a regional issue. When we talk about air pollution in India, so basically, regional background plays a very important role. And you will be amazed to know that in India, specifically for PM10, if we shut down all the sources, still the concentrations that we have as a regional background, we will never be able to meet WHO's air quality guidelines.
Clear early example of this is that Beijing's, the capital's steel industry, was relocated to the surrounding province of Hebei in the run-up to the Summer Olympics, which were in 2008. And then that industry that was located some hundreds of kilometers away from from the city just grew to be so big that it still became the number one source of air pollution for the city in the following decade. The other very typical distortion is that people mix up the sources of emissions in an area and the source of the pollution in the air. So you ask, why is this city polluted? And what you do is you look at all the emission sources within the boundaries of the city, and you say, these are the sources that are polluting the city. But for a typical city, about half of the pollution is going to be coming from outside. And then you're missing all the sources and for many cities, there are not going to be that many power plants or industrial plants within the city boundaries. So typically the sources that are missed are going to be industrial and power plant sources, or then it could be agriculture and so on.
And so the fact that the issue isn't necessarily local leads to issues in terms of responsibilities.
Yeah, you have rightly pointed out. So the governance mechanism needs to be improved. The funds are being provided to the urban local bodies, while the reporting is being taken from the pollution control board. So they are not being provided with the funds, but they are being provided with the responsibility of reporting. There are sources which are located outside the city boundaries. So if I am responsible, I am a city administration, I will not look beyond my city boundaries. So out of these sources, you will see the major sources. For example, industries are mostly located outside the city boundary. They do not come under the purview of the city administration. Most of the biomass-based cooking happens in the rural areas because the urban areas still have a good percentage of the LPG penetration. So those areas does not come under the purview of the city administration, and they comes under the purview of the pollution control board, rural development department, or under the purview of the state government, but the funding is not with them. So Andreas, Terry has done the estimation of air pollutants emissions at a national scale, and what we found that residential biomass burning does not seem as a big issue at a city scale, but if you talk about national scale, it contributes almost 25% of the total particulate matter. So the residential biomass burning cannot be left unattended or unfocused. So that's a very major sector wherein a lot of efforts needs to take place.
Another way to interpret the fact that these emissions aren't local is also to acknowledge that many goods and services consumed and demanded in certain countries are produced in countries on the other side of the world, which increases air pollution for those local populations, but also CO2 emission. Another reason why we can call air pollution a wicked problem is how it is interlinked with other issues such as climate change. For example, heat waves can exacerbate ozone pollution by speeding up the chemical reactions that form ozone. And since cities can be mini heat islands and have loads of traffic and thus nitrogen dioxide and volatile organic compounds, this can create a perfect combination for high levels of ozone. But ozone is also greenhouse gas at the same time, so it can kind of act like a mini loop. Another example is with wildfires. Increasing wildfires due to heat waves also increase air pollution such as PM 2.5, PM10, black carbon, and VOx. The use of coal for cooking and heating also emits emissions. Oh, and the massive elephant in the room is coal-fired power plants, of course, as well as any form of combustion really of fossil fuels such as in cars. But I cannot make a video on air pollution without talking about the inequalities of air pollution and how different groups are affected unequally. So first, demography.
Some parts of the population are more likely to suffer from pollution-related disease. So they're more susceptible to air pollution-related disease. So young children and the elderly, for example, pregnant women are more susceptible to air pollution-related disease.
Children face special risks for two reasons. One, children breathe more air per unit of body weight than adults and have less effective nasal filtration, which makes them more vulnerable. 2. Children's bodies are more affected since their bodies and immune systems are still developing. In many countries, children can be heavily affected by indoor air pollution, especially from cooking, as the caretaker needs to both cook and care for the children. And this impact on children is often amplified for children who live in communities that are socially or economically disadvantaged. The global burden of disease can also increase in certain areas due to changing demographics, namely aging populations, which are also more vulnerable to pollution and health adversity. But it's also unequal socially, with certain socioeconomic classes and minorities being more affected and being less able to adapt.
It's also something where we see a lot of inequity. We do see that where there's wood burning, there's real challenges. So particularly, again, in those kind of more lower income countries where there's reliance on solid fuels, indoor air pollution can be very, very poor. You can have very high levels of pollution within a home, and that also causes gender disparity too. So where there's traditional gender roles in terms of cooking and being in the house, women can suffer in terms of their exposure. And actually there's reports of kind of self-reported health being much worse for women in these situations. You also find there's studies that are from London that have shown that more deprived areas and lower income areas actually have some of the higher air pollution. They might be around busier roads, for example. And then that means you've got people who are less monetary equipped to make changes to their life, living in areas where they've got really high air pollution and are potentially more likely to suffer from disease. You even have racial distributions. So there's studies from the US that I can send you, and they show how certain demographics are more exposed to air pollution than others.
Nowadays, air purifiers are so famous. In every other offices, you will see air purifiers, right? So the rich class can afford air purifiers, but how about the lower and the middle income class? They are the people who are earning almost their daily wages and getting more exposed to the air pollution. So it's not only the gender inequality which plays a role over here, it's also the socio-economic and the equity related issue as well, in my opinion, which one needs to look at.
But it can also be complex in other ways. Sometimes it's not just a few individual big plants, but also small and medium enterprises and the informal sector.
The other share comes from the medium and the small scale industries. Mm-hmm. So most of the large scale industries are organized sectors. While in case of the medium and the small scale industries, it is still an unorganized sector, which does not have a very good technology and air pollution control devices, because of which this sector is a highly polluting. Plus, on top of that, there is no right reporting of the sector.
So now to the more positive side of the video, solutions.
So there's lots of good news on knowing what works for air pollution. We see case studies from all around the world of people doing different things, whether that's behaviour change policies, technological solutions, clean vehicles, electric vehicles, for example, being a technology solution that we know they have lower exhaust emissions, no exhaust emissions compared to combustion engines. We know that if you cycle over rather than take a car altogether, that also lowers air pollution. We know the things that work as scientists.
In 2024 alone, Brazil, the US, European Union, Uganda, for example, announced stricter regulations on air quality. So, how do you come up with solutions? Well, you tackle the different sources, with some solutions tackling different problems at the same time.
I think the key thing to note with the wicked problem is it sounds very damning. It's like, oh, this is horrible and it's a big mess and how are we ever going to solve this? And there are a lot of challenges about how we're going to solve it. But it also means there's a lot of opportunity to simultaneously solve multiple challenges and simultaneously make cities and other parts of the world better places. So we know that a lot of air pollutants, black carbon, for example, is a super pollutant. It comes from burning carbon sources. So wood burning, for example. If we reduce that, that's a toxic air pollutant. It can rapidly improve public health, but it's also a super pollutant in the fact that it causes warming of the atmosphere, and it has a much shorter atmospheric life than carbon dioxide. So you can see really quick reductions in warming by reducing black carbon. That's combining air pollution with climate change, and we haven't even thought about the social benefits yet. the things such as noise pollution, and how if we stop having cars burning fossil fuels, you're also going to reduce the noise, for example, on streets. That has better mental well-being and health benefits for communities.
Now, solutions when it comes to coal power plants is to use certain filters or just close them. Or as the COP30 agreed on, phasing out fossil fuels. Oh no, it didn't. But the benefits of closing them are significant. This study looked at the positive benefits in terms of lower mortality for local populations after closure of a coal power plant, and this one found large reductions in asthma-related hospitalization and emergency room visits after the transition away from coal for one plant, and in other cases, simply installing emission control technologies for sulfur dioxide. Here, average annual PM2.5 concentrations for downward wind counties from a coal power plant decreased by 8 micrograms within 5 to 9 years of the closure of a plant in China.
Whoever covers the cost of healthcare, increased productivity for employers and employees, building property owners whose property values go up because the place where their property is more attractive to live in, and so on. A lot of our work is on pollution from coal-fired power plants, and the thing about the sector is that first of all, it's a very small number of sources that you're dealing with in most countries, like South Africa, a couple dozen power plants, even India, a few hundred. So compare that with all the vehicles on the road or all the farmers or whatever. It's a very manageable group of sources that you can inspect individually and enforce emission regulations individually. But the flip side of that is that it's politically and economically powerful. The other important thing about coal plants is that there are technologies that are very well established that can reduce the pollution to a fraction of what you would have if you don't have emission control devices in the plants, and it's very well established that the economic benefits from removing those pollutants before the flue gas goes into the air far exceed the costs of installing those technologies. But it's the simple fact that it's the plant operators that have to pay for the cost of installing and operating those control devices.
But it can be both easy and difficult to tackle emissions from coal-fired power plants.
It's a classic political economy dilemma where the costs are very targeted and the benefits are very dispersed and widespread.
It can also be a politically charged issue.
And the real poison for politicians in, let's say, South Africa or India is if the power plant operators can always blame the politicians for increases in electricity costs, increases in power shortages, which are chronic in both countries, not because they don't have enough power plants, but because the power system, frankly, is a mess. But still, if you do something that requires something of the plant operators, you can always be blamed, and it doesn't matter if it's factually correct. It's just the operators can threaten that, we're going to pin these things on you if you require us to do anything, and that's how they keep getting away with literally poisoning the air for everyone. And of course, they have a very strong hold on the research community. They can always hire very serious-looking, credible consultants and researchers to come up with studies that distort the facts to say that their contribution to pollution is small and it would cost too much and to clean up and so on.
Eskom in South Africa is notorious for breaches in emission limits, delays in the installation of emission controls, and delays in plant decommissioning. So if you close a coal-fired power plant, what you want afterwards is replacements, like with public transport for cars. So in the case of coal power plants, for electricity, it's investing in renewables, the grid, and energy storage, for example. In the case of certain heavy industries such as steel, it's electrification of certain industrial processes that currently rely on coal. So in terms of framing of goals, it's important to not only link decommissioning of coal power plants to energy or climate targets, but also to public health targets. Some more solutions. I and many others, I'm a big fan of active urban mobility as a solution and reducing car usage, which not only has many positive health benefits, but just makes cities much nicer to live in. It can make better use of public spaces, reduces stress, noise pollution, which if you have lived in a house near a loud road and with British windows, then you know how much it can affect your sleep. But it also decreases traffic accidents, which surprisingly killed more people than I actually thought it did. The low emission zone in London did heavily reduce air pollution after its implementation. Another case of implementation of solutions is Beijing, where many actions were taken, such as closing polluting factories and sources, increasing vehicle emission standards, but very importantly, investing in alternatives to cars, so public transportation. Not only is phasing out fossil fuel vehicles necessary to limit climate change, but also for air pollution, particularly in cities. But for the cars that we do keep, electric cars will heavily reduce emissions. Although some people will point out the non-exhaust emissions from electric cars, which we should definitely not ignore, it's not really a fair point when comparing with fossil cars, since even when it comes to the non-exhaust emissions, some studies show that they actually emit less PM10 and PM2.5 depending on the weight of the car. And also, most comparisons of pollution from cars between electric and fossil always forget to take into account the PM2.5 emitted by fossil cars indirectly through precursor gases like ammonia, as we saw previously. But it's not just about cars, since other vehicles can pollute a lot too.
There would be sectoral solutions that one needs to consider. So definitely in case of the transportation, if we take rid of all the older vehicles, specifically which are like 10-year or the 15-year older vehicles, so there will be a significant improvement in air quality, specifically for the heavy duty vehicles. So when we prepare city level inventories, so most of our pollution share in case of the transport sector comes from the heavy duty vehicles. And that too is like older polluting more than 15-year-old polluting older heavy duty vehicles. So if we convert all these heavy duty vehicles to a newer technology, the air quality is going to improve significantly.
Banning stuff in general can work if alternatives are given, especially to lower income households, such as China's combined heat and power policy, banning household coal burning, but gave subsidies for electric or gas powered heating.
In case of the residential sector, definitely LPG penetration is must. Even to improve air quality, now cities have the LNG network, city gas distribution networks. So even if that network can also be extended to the slum areas, and compressed biogas can easily be transported through the city gas distribution network. If that can happen, at least in the urban areas, in the slum pockets, the pollution can be reduced.
Electric stoves, solar energy, biogas, gas and LPG have been ways to reduce indoor air pollution for cooking, for example. However, one note on gas, specifically if it's not biogas, and developing large gas networks, can be the potential for an infrastructure lock-in where large investments are made, which then makes it harder to shift towards renewable energies, so IMO, not the best solution. Tackling air pollution from waste is also very important.
The third thing and the very important thing is the waste management. Waste management is still a very big challenge. If a proper segregation of the waste can happen, that can reduce refuse burning significantly and can also provide wealth from the waste.
So what are some potential challenges to implementation of solutions?
The challenge comes in implementation, but maybe not in what you think. So there can be challenges of opposition. So this can be people not interested or opposing to a certain solution. That isn't always a thing that's limiting overcoming such wicked problems. So there's actually been a lot of research into policy making and how we make decisions. And there's a lot of siloed thinking. So to really tackle air pollution, you don't necessarily need the air pollution scientist on board. The people you need on board are the communities, you need the transport people, you need the people potentially in the climate change department to understand the links with the air pollution. You need the people in homes and building and urban planning to understand how all of their decisions are actually influencing air pollution. And we know that these people tend to work in silos.
So how can we tackle siloed thinking?
So there's this whole school of thought around systems thinking and how we can promote cross-collaboration, how we can investigate how climate and health and environment are interlinked and we address them in a more cohesive way. But that's something that's still challenging and something that we still need to really think about how we'll implement that in practice. It's done a lot in theory, there's a lot of talk about cross-collaboration. In practice, it's a much harder thing to achieve.
Another important part of the solution is data.
So data is a really interesting part of air pollution. Effectively, without data, we can't see the problem. And without that, we then don't have the demand for change.
So, Andreas, definitely data plays a very important role. You can't control air pollution if you can't measure it, right? That's a very old saying. You can only control what can be measured.
When you don't have data, you don't have accountability.
So that means there is massive communities of people who aren't aware of the magnitude of the problem where they live. And without that data, how do we monitor progress? How do we drive demand? And that same group have also found that when you introduce a single data point in a data scarce area, you actually see the air pollution drop quite quickly.
You don't have accountability. You don't, and you don't have a way of telling whether certain measures that you took had an effect or not, and so on. And especially if you're a low-income country or poor country, and you need to make the case to potential funders for measures or programs that would improve air quality, then obviously if you don't have the data, then you don't have a whole lot to go by. And also then when we talk about modeling studies, it's essential to be able to validate the models against measurement data. So there's so many reasons why data is important.
But it's not just about having the data, but it needs to be understandable and usable and also analyzed.
The thing is that the people are not aware, most of the people are not aware how to interpret the data and how to make sense of the data. So for example, if I will give you a number that PM 2.5 concentration in Delhi is 200 microgram per meter cube. What inference are you going to take out from this?
However, something that's come out of our own research recently is that yes, you need data, but that data needs to be usable, accessible, in the right formats, and actually understandable. We've had a quote in our structured decision-making paper actually from a local authority who just said, we've had data for years, but we just haven't used it. So it's about making sure that not just having data, but the right type of data in a usable way.
For a lot of countries, the big gap right now is not the availability of data, but the fact that there are way too few people actually making sense of it and analyzing it. So obviously for large parts of Africa, of developing Asia, you do have a severe lack of data. But for other countries, China, India, Europe, even North America, and so on, you have thousands and thousands of sensors delivering data every hour of the year, and very, very few people do anything with that data other than just maybe calculate year-on-year changes in averages, and there's so much more that could be done.
What and how we monitor air pollution is also important.
Across the country. But the problem is that most of these stations, they are located in urban areas. They're not located in the rural areas. So they are not a true representative of the problem that is happening in the country. Plus, most of these stations, they monitor only PM10 2.5. We are not even having a limited monitoring of the other important pollutants such as ozone we talked about. Saddening that our complete focus is only on particulate matter, and we do not have done even a monitoring of ozone in India. There is a very, very limited monitoring of.
Quite a few places in the world have low-cost sensors installed by individual people, even installed by institutions, which are great, but to work well we need a combination of high-grade monitors and those sensors. So in an ideal world, the sensors will be providing much more, spatial detail. But you have at least in every city, you have at least one high-grade monitor that gives you a strong reading on the overall absolute levels, and you can validate and calibrate the local sensors against that.
So at some of the locations, the monitoring stations are not located at the places where they should be. Either they are located too close to the source. So the purpose here is not to do the source monitoring, right? We want to do the exposure monitoring, what we are inhaling. Or they are located in the too much of a greener areas, which basically represents the background condition.
Due to certain obstacles, let's say, creating communities and public pressure is needed in order to drive change and solutions. So for example, how could you be part of the solution? The first step needed is awareness.
What plays an important role over here is the awareness and sensitization. So people are still not aware enough and sensitized enough to raise a demand. So political will comes in when the people raise demand for clean air. And nowhere in the election people ever raise that we need the city air to be very clean. We should be meeting the national ambient air quality standards. We need breathable air. So when the demand is not there, so the political will also not be there.
One of the best ways to create demand for change is together through communities.
I guess one key place to start is look to your community. Is there already groups interested in air pollution? And are these groups already talking to policymakers, to scientists? There's really good examples of this from groups at Imperial and in London where they're working with local communities to address air pollution. So look for those community groups, because often when we work together, that's when we kind of find those common threads and can start to identify where there's levers and where we can integrate with different people who have decision-making capacity. So community engagement is great. That's a really good place to start.
And there are many examples of where it does lead to change.
That most jurisdictions in the world have eventually managed. So eventually the pressure from the public for cleaner air and efforts by civil society organizations to highlight how politicians are letting these companies pollute the air have just shifted the balance and eventually gotten strong regulation and enforcement in place. And even South Africa and India, those are countries that even got the regulation, so the public pressure went far enough that they got the regulation in place. But it's then when it was time to enforce that regulation that the decision makers have balked so far.
Another example is where many young people, as usual, in South Africa mobilized to cancel coal through litigation, which in 2024 led to a High Court decision halting government plans to build out 1.5 gigawatts of coal-fired power capacity. Other things you can do as an individual, even though it is a more sustainable problem, let's say, are...
The general sort of things I think that everyone can do is going more by a non-motorized mode of transportation, or using public transportation versus using private transportation. This is one small step I think each one of us can easily do, specifically if there is a ample public transportation available in our vicinity.
An interesting thing that affects how outraged or aware we are about air pollution is our perception to exposure to air pollution.
In general, the rule is that people will only think about emission sources that they can see. People who can see the stack of a coal plant will think that they're affected. Those that are one hill beyond that and can't see it won't realize and will even have a hard time believing that they're affected. The confusing thing is that there are exceptions. So when there's a forest fire episode, people have no problem grasping the fact that the smoke from forest fires can travel 1,000 kilometers, several thousand kilometers. But the confusing thing for me is that why is it so hard to get your head around that that's happening all the time? The air that you're breathing has always traveled, forever in a way, but for hundreds and thousands of kilometers. So it's a mix of pollution from all the emission sources along that trajectory that the air has traveled, that you're breathing. A single coal-fired power plant 100 kilometers away will be a small part of that. But when you have a massive cluster of coal-fired power plants, like there is, for example, next to Johannesburg or Jakarta or Beijing or Delhi, then when the wind is from the direction where you have those coal plants or steel industry plants or whatever, then it's going to have an impact. But it's just when you're not thinking about it, when you're not thinking about how the air is moving and so on, what you're gonna be seeing is just that there are cleaner days and dirtier days, and you won't be able to form a pattern in your mind of why does that happen. So we're very good, like as just the human senses are very good at detecting small changes in pollution levels when the pollution levels are something that you can feel. So people have this very clear daily experience that when you go from a busy road to a nice park, for example, that the air gets a bit better, and it can be a really small change, but you can feel it, and that gives you a very kind of concrete experience of how cars and other emission sources on the road affect the air quality. But we just lack that. If you haven't looked at wind maps and maps and so on, we just lack that for, let's say, large industrial sources or other large pollution sources that are far away.
So we know that public awareness and education campaigns are also very important, and the media could and should play a better role in informing people on this very important matter. I haven't gone through every solution to every source of air pollution because the video would be even longer than it currently is, but I hope you got the picture. I also could have gone more into other pollutants which are starting to get more attention, such as microplastics and ultrafine particles. But in conclusion, we really should be paying way more attention to air pollution, but also acting on it, since it's literally the second biggest risk factor of deaths, and I repeat, kills at least 8 million people per year. The good news is that more cities and countries are slowly meeting WHO guidelines and are tackling the issue, and also that tackling air pollution has so many other benefits, such as reducing greenhouse gas emissions, noise and water pollution. So I hope you learned a lot in this video and that it inspired you to go close down a coal power plant. Just kidding. Thank you so much for watching. If you like this video and want to learn more about climate, energy and environment topics, don't forget to subscribe. In this video, I made these animations myself from real data, so I will put the workflow and Python scripts in a GitHub repo for anyone interested.